of the SQL training with a real life case study. So today we are going to look into the working with multiple tables. So far, if you see in our sessions, all the previous sessions, we have worked with a single table, whether to populate data or whether to retrieve data and applying filter. So everything we have done with a single table. So we are going to see how we can work with multiple tables. Okay, so here we are in the lesson 7, and we are going to see specifically the joins. Okay, joins plays an important role in SQL. Join concept we are going to learn. We are going to also learn how we can use join in DQL and DML statements. So case study recap is right now we are working with a chain of restaurant who wants to build an application to capture, store, process and report their daily business transaction. Okay, so so we have already seen, and we are building this application to build a important business question, right? So the app should help them to know what's happening with their business. Okay, and today specifically we are going to see total item quantity, item type wise. So we are right now going to join, right? Because the total item quantity is from one table and item type is another table. So similarly, list of item quantity is one table, and day wise, if you want to show, it is in another table, because order header has the day information. So like that, we need to join 4 different tables so that we will be able to get these results. Okay, so that's what we are going to learn. Before that, let's understand what is a join concept. So why we have to join? Because data in a database exists in multiple tables, right? So because of the level of information, for example, the customer information stores only customer related information, whereas restaurant stores only the restaurant related information. We cannot put all the information into a single table, right? It defeats the purpose of normalization. Because every entity will have its own data, right? The level is very important. For example, order table will have order information belongs to multiple customer, right? The same customer multiple order also will be there, and also it will have multiple customers data. So because of which I cannot store the order related information in customer table, right? So because of that, if you see, we end up creating different tables for each of its purpose, based on its grain, based on the level of information, based on what information it's storing. Okay, and why? Okay, so now we understand multiple tables are there in a database, and we store different data in different tables. So now what is the need to retrieve data from multiple tables? Why can't we individually separately retrieve data from each table? We cannot do that because sometimes or many times we have to combine table data. For example, if I say I want to find out the restaurant location wise total ordered amount, total sales. So if you see the restaurants, the location is available in the restaurant table, whereas the order related amount or quantity information is available in order detail table, order item table, right? So totally two different tables. We need this information because then only we will be able to relate and then make a much more meaningful insight we will be able to get. So some cases we will be getting data from two columns, two tables, right? We will be joining the select columns, a few columns from one table, few columns from a second table, few columns from third table, and so on. And in some situation, the filter condition will be based on second table, whereas the select columns from the first table, right? There will be some situation where, for example, if I want to see the sales data only, the restaurants belongs to Bangalore, right? Then I have to apply filter on restaurant table, but the sales data has to come from order item table, right? And similarly, sorting columns. For example, if I want to sort it based on date, the sales based on date, because the sales information is available in order item, whereas the order date will be available in the order header table. So then only I can sort it based on day wise sales, and grouping also. So grouping also, if I want to group by customer or group by restaurant, then I have to group, right, different table. So there are much more scenarios where we have to join multiple tables to get the desired business output. So these are the examples that I talked about for some of the scenarios why we have to join multiple tables. So in the join, the first join is the inner join. So inner join is the first join. It is also called join. Okay, inner is an optional word. What it does is it fetches common records from both the tables. Common records from both the tables based on the key joining column. So when we join two tables, we have to specify, okay, so the joining is happening based on this column or the set of columns, two columns, key columns. Because otherwise we cannot join two tables, right? If they are not at all related, we cannot join. We can join only the related tables based on the key joining columns. So what happens in inner join is when we join using the key joining columns, right? We fetch the data only which exists in both the table. We fetch the records which exist in both the tables. It's more of an intersection of both the tables. So when you see with the data, you will get an idea. For example, when I join customer and order table, it will retrieve data from both the table where the customer data exists in both the table, because customer is a common, right? So customer ID exists in order table as well as customer master table also as a customer ID. We'll be joining using customer ID, and if you use inner join or the join, it fetches only those records which has data in both the table. Okay. Otherwise, for example, if there are a customer, for example, Prince is a customer, the data is there only in the customer table. So the customer does not have any order. He has not placed any order yet. So he does not have any record on the right side table. So what will happen? It will not bring that record because it is only available in one of the table. So the syntax for inner join is the table A join table B. You can use inner join or you can use join simply. And we will have to specify the joining conditions or based on what column we are joining, right? It could be a single column or it could be multiple column, right? So we will have to specify that. So let's see using the query. So we have the customer table and we also have order header, right? So this is what I'm trying to do. I've written the query and I am executing. So when execute, it fetches all the matching records. For Raja customer, there is only one order. For Rani, there are two orders. Okay, there are two orders. So all the information, the customer wise order that you will be able to see when we use the join condition. It could be a inner join or join, right? So inner also we can use. It's an optional word. Same results it will fetch. Okay, and after inner join condition, what we can do? We can add the where condition. So the join condition is different from where condition. So this is the main table. This is the main table, and this is the joining table, right? This is the joining table, and this is the joining condition. So it could be one column based on one column or multiple columns. In this case, it's only one column. So let's say now if I want to only see Rani's orders, then I can put a where condition. So this is called where condition. This is different from join condition, right? Yeah. So like this, we can see we can apply where condition, which is totally different from join condition. Okay, join condition is primarily for matching the records to perform the join operation, whereas where condition is primarily for data filtration, right? So filtering the data in the output. So now, and the table join can be used directly, or we can use a table alias. So if you remember, so far on the lesson 4 we saw what is a table alias. Table alias is we can give an alternate name, alternate alias, right? So I can use A, or I can use cust, or I can use customer, whatever that I want to mention, or I can say C1, right? Some people use CO and OH because C means customer. It's easy to understand instead of A and B. So I can change it to C and I can say OH, right? So this way it will be easily understandable. If I look at the code, it's easy to interpret rather than the previous one. So instead of saying customer.customer ID and order header dot order customer ID, I can simply say oh.ch dot. So it's easy. It's very intuitive. It looks a simple code. It simplifies the whole query. Okay. So now going back to one more example. So I can I use multiple table in the join? Yes, we can use. It's not just only two table we can join. We can use, in fact, another table. For example, if I want to join the restaurant also, then what I can do, I can join restaurant. Let's say if I want to show which restaurant this particular customer ordered. Okay, so then I can keep that name as a R, and then I can give a condition which is R dot restaurant ID is equal to OH dot restaurant ID, and then I can say restaurant name first, right? So in the this thing R dot restaurant name. So now we are fetching data from three different tables. Okay, so this should be C dot, right? Yeah. So now we are going to see data coming from three different tables. Okay, data is coming from three different tables. Let me say locality, right? So locality will be different. At least it will show better data. Okay, so one person has add in Bangalore, one person, right? Jubilee Hills, Adyar, yeah. So now any number of table can be used. I think in some of the production environment, I've seen people use for some 20-25 tables for complex joins. Okay, to address it all depends on the business scenario. So now we have seen inner join. So we are going to now look into the second join. This is called left join. This is also called outer join. Okay, left outer join or left join. The outer is an optional word. So what happens in the left join? I'm keeping left table as a main table. Okay, I'm going to bring all the records from the left table irrespective of whether record exists on the right side table or not. Okay, and I'm going to bring matching records from the right side table. For the missing records, I'm going to show null. So that is what will happen in case of left outer join. So this is an example using a Venn diagram. So that it is going to bring all the records from the left side table, and it is going to bring matching records from table B, and it is going to show null value for all the table B missing records. For example, as I mentioned, Prince is a customer. He has not yet placed any order. Okay, his record is there only in customer master table. So it will show on the left side table. If I use left join customer, it will show left side table record. For the right side table, it will show for those matching records, it will show value. But for the missing record, it will show null value. So this is how the left join will work, right? Which will bring all the records from the left side table. Okay, so the syntax is pretty much the same except that the left keyword is being added. Okay, so using this, if I want to find out, give me the customers who have not placed any order. Then what I should do? I need to put where condition only the right side any column equal to null. Then it will bring Prince, right? So that way we will be able to address the question. For example, this is a left join. So I'm using customer and order header. In this example, we are getting Jennifer. Jennifer is the customer who has not yet placed any order. Okay, so now if I need to find out the business question is, give me the list of customers who have not placed any order. So what I should do, the data does not exist in the order header, right? So dot customer ID is null, right? Any column we can just mention. So if you execute this query, what will happen? It will only bring those customer who have not placed any order. So this way the business question can be addressed using this condition. Okay, so it's extremely important for left outer join. The right join is exactly the opposite of the left outer join. It will fetch all the records from the right side table irrespective of the record existence in the left side table. Okay, so it will bring values from the left side table for the matching records, and for the missing records it is going to bring null. For example, let's say if there is a order which has been generated against a guest customer. Let's say there is no customer, valid customer, one time customer. So they have not created any customer data for that customer. They have just gave the parcel. Okay. So now if in such scenario, if I use right join customer on the left side and order on the right side, so then this is how the data output will come. Okay. Because for this customer, for this order there is no valid customer. So it will bring all the matching customers from the customer table on the left side. For missing records, it will show null. So for using this approach, what kind of business question that we can answer? Give me all the orders which are raised against one-time customers whose record does not exist in the customer table. Right? That kind of business question can be answered using right join. The syntax is just instead of left, we will be using right. But the what table we specify on which side is very important. On this is the left side table, this is the right side table. Okay. So since it's the same syntax, I'm just moving on to the next join. So next join is a full join. Full join will kind of get all the results, right? We will fetch the records from both the sides of the table, right? And it will bring the matching records from the other side of the table, and it will show null value for the missing records on both the sides of the table. So if you see, for it will show Prince record, and it will show null on the order side, and it will bring order 987 on this side left side, and it will show null for the customer. So this is what the full join. Full join exam, the syntax is just full. We'll have to specify. So in all such scenario, the outer is an optional keyword. Okay. So if I go back to the full outer join, so full outer join, so multiple join condition we have seen, and full join, right? So order and customer, if I execute in this example, so it will show Jennifer, right? Jennifer for the order, it is an empty in this example. But in this example, I don't have any order without customer. Okay, so that's why it is not bringing other record. But that's how the full outer join works. So going to the next join, this is called cross join. So cross join generates Cartesian product. Cartesian product meaning all possible combination between two table records, right? So let's say if there are two records in table A, two records in table B, it will generate four combination, right? First record with of the table 1 to with the first record of table B, and first record of table 1 to second record of table B. Next is the second record of table 1 and first record of table 2, and second record of table 2 to with the second record of table 2. So this is how it will generate all Cartesian product. So for example, if you want to generate, give me all possible combination. So customer, give me all the list of customers along with all the possible items that they can purchase, right? So it will show all. So in this example, I've used only 3 customer and 2 items. So the all 3 customers can buy these combination. Right? These combinations are possible. If you want to generate all possibilities. And the syntax is cross join table B and the join condition, right? So cross join. So for example, I'm just doing cross join of item and customer. So if we do the cross join, what happens? It will bring all the customer for all the items. Here I think there are around 16 items. All 16 items will show against Raja customer. Second customer, then it is showing 16. Third customer. So it is bringing all permutation combination. So I want to tell you like one real life example where this cross join will be very much helpful or people use is for example in case of cricket IPL, right? So for the league, all the teams play against all the team, right? So all the possible combination needs to be generated, right? So team A, team 1, team 2, team, let's say if there are 10 teams, then team 1 versus team 2, team 1 versus team 3, team 1 versus team 4. So like that, we need to generate all possible combination for the round robin league, right? So for that, I think we can use cross join. So it will generate the all permutation combination. So now going back to the one more join, this is called self join. Self join is nothing but referencing the same table more than once in a query. Okay, referring the same table more than once in a query. Okay, so any join we can use. And so what all are the scenarios when we may go for self join? So there are two scenarios primarily we go for self join. One is related record. So if you want to work with related record, for example, employee record along with the manager record, parent record along with the child record, or finished product with raw materials, right? So both has a relationship. So if you want to work with a related table, both the records are wherein both records are exist in the same table. For example, manager is also an employee, right? So manager record also will be there in employee. Manager record will also be there in the employee. So this is an example where if you see, these are the list of employees where, for example, this Mukesh Singh record. So his manager is nothing but 2070, no, 2,73,000. So you see, he himself is an employee because manager is also part of the payroll and they are part of the employee organization, right? So there, his record and his employee record is 2,51,000. So who is also an employee. So like that, if you want to find out, let's say if you want to print the employee name, then side by side, if I want to print manager name, then I have to you go for self join. So I have to join this table and join the same table with another alias, right? Employee is one alias and manager is another alias. So this will be employee dot manager, and that is employee dot name, and this will be Unnat Nayar will be manager dot employee name, right? And the joining condition will be the table A's the employee supervisor ID is nothing but table B is employee ID, right? That's how we'll have to go for self join. And then second scenario where when we go for self join is sequence record comparison. For example, I want to compare previous year sales with current year sales, right? I want to do year on year sales comparison. I want to do day by day change, right? I want to see month on month analysis. Let's say I want to compare two records based on some sequence, right? So I want to see the previous year result versus the current year result, right? So in such situation, I can go for self join. So because I need to compare two set of records based on a timeline, right? So I can use that. And in case of self join, we can go for inner join, left join, right join, full join, cross join, anything that we can do, because it depends on the business question. For example, if you need to, in this case, let's say if you go for self join, inner join, if you go for inner join, it will only show all the employees who has manager, but it will not bring Vijesh say the record because he does not have any manager record, right? So because if we are going for inner join, so there is no manager, only one side record will come, second side it will not come bring record. But if you want to bring the record of the employees who does not have manager or who are the top level employees, then you may need to go for left join, right? So that the employee, even if they don't have a right side table record, it will bring. Okay. And cross join, you can go in case of IPL, right? So same team, 10 teams, you take an alias. So one is called now the team and second is called opponent team. So both will be the same, right? So you can use the condition to generate. So now we are going to learn about DQL statement with join. So we can use table alias that we have seen, and inner join, left join, full join, DQL. I think all these examples now we have seen, right? We have seen join condition versus where condition, right? Full join we have seen, cross join example that we have seen. Now we are moving to DML statements with join. So DML statement is primarily for inserting, right? So inserting, how do you insert data based on table, second table and third table? So what we can do, this is nothing but a DQL statement. So you write a DQL statement and then insert into a table. So here I've just put A, but we have to give table name actually, but we cannot give an alias, but we have to give a table, which table that we are going to insert, right? This is nothing but a table name, right? So that is how you should see, this is not an alias. Okay, and we will be using this statement to insert data. So this is how we will be using the join in a select statement to insert data into the target table. And in case of update table, right, so we will be joining two tables, and based on condition from one table and based on join condition, right, everything is the same except that the update statement will have to specify what is the target table. So which table data it's going to we are going to modify, right? So and then we are also going to specify what all are the list of column that we are going to update. It could be one column or multiple column, right? And we have to specify what is the source table. This could be from the same table or this could be from another table, right? So we need to be very clear what is it. This is here we don't need to specify a dot because we are specifying the table A is column is going to be updated. So this is how we can use a statement to join two tables, more than one table, to update a record, to update records, right? So of one column or multiple columns. And finally, we are going to see delete using join. So we can join, sometimes no, we have to join with another table to find out, okay, what is the condition, right? So sometimes condition we'll have to depend on the second table. It could be existence of record or it could be non-existence of record from the second table. So that's why we may go for joining, or we may go for some value checking. For example, city equal to this value or so on and so on. So in such situation, we'll go for table join for deleting records. Okay. And today we are going to see how to join tables to get the total item quantity and total item amount based on another column name, right? So that's what we are going to write now. So we are going to write, for example, the question is customer wise, right? Let me take this example. So this would be pretty straightforward. Okay, so I'm going down. I'm going to write the business question. So what is the business question? Business question is, so total list total item quantity, list total item quantity, item type wise, item type wise. So when we say by item type wise, right? So what we need to do, we need to join um, item table, right? So with item table. So what all we need to join? We need to join the order item table with item table. Okay, so let me, I think, write better let me write for a new query. Select star from item, this is called a I, and then I'm joining with order item table. I call this as a OI, and then I'm giving a join condition on I dot item ID is equal to OI dot item ID. Okay, so now the question is total item quantity, right? So total item quantity, item type wise. So item type has to come from menu order item table, and then OI table will give us the total quantity, right? So we need to go for total quantity because the question asked is total quantity as total quantity. Okay, so we need to group by. We need to go for group by I dot item ID, I dot item type. So now we are able to answer this question. When we execute, we get item type wise, we are getting the total sales quantity. Okay, item type wise, we are getting the total sales quantity. Okay, so the same way we can find out item type day wise if we join with order header. So I'm not going to go for that, and I'm going to go for customer wise. We'll see, find out. So now if you see, we have already written the join. So what the question is, customer wise, we need to find the sum of total sales uh, amount. So we need to go for separate because we need to join with order item table. Okay, so I'm going to join customer table. It's called C, and I'm joining with order item table because order item table has the amount, and I'm joining. I cannot join these two tables directly. Can I join? I cannot join because I need order header also. So first I need to join with order header. Order header first I need to join based on C dot customer ID is equal to OH dot customer ID, and then I'm joining with the OI, and now OI dot order ID is equal to OH dot order ID, right? So now only properly we have joined, and now the join condition is C dot customer name. So customer name wise I need to find the total OI dot item amount. I think item amount, let's see, if it is wrong then we will change as total amount, right? So we need to group by C dot customer name. So now we are going to get the total amount. By customer wise we are going to find the total sales, right? Customer wise now, right now we are getting. So this is possible only because we are able to join two tables, two related tables. So what is the business question here we have addressed? Business question is to list, what is the question? List item amount customer wise, list item amount customer wise, right? So Now we have solved this business question. And if you want to, in case if we haven't tried group by, then what you can do, just select star, and then we can, what we can do, we can go for, if you simply need only the item related information, you can just simply go for join. Right? If the question is not for grouping, then what you can do, put I dot item name. For example, item name, I can go and I dot item type. Then I can say OI dot item rate we have, right? So item rate, then OI dot item quantity. Then I can say OI dot item amount, right? All this information that I can simply by joining I can display. So this will give for each order, what is the, for each item, okay, what is the price and what is the rate and what is the type. So we can get the detailed information. This is also possible. Then in case if the business question is asked to group data, so you can also apply group by. Okay, so with that we have come to end of today's topic, and I'm going to go to the quiz of lesson 7. So let's see the first question. Inner join in Venn diagram. In Venn diagram, so what is a inner join? Inner join is not, is it union? Is it intersect? Is it union plus right, or is it right plus left? So this is intersect. So intersect is the thing, because it the inner join will get the common items, those items which exist in both the table. So moving on to the second question. Which join to use to get manager record? Manager record, right? So is it inner join, cross join, full join, or self join? Yes, it is self join. We have to use self join to fetch the manager record. Which join gets all data in the result set? Right? Which join will get the all data result set? I think this is pretty easy to inner join. Is it left outer join, right outer join, or full outer join? It is full outer join. Okay. And final question is, which syntax is correct? Is it first one from table and then on condition, and then finally we have join? So this is not right, because we can only give join condition after giving the specifying the join, otherwise we cannot specify. Moving on to C. So from table, from we cannot have more than once. From we can have only once. The second should have been a join condition. Similarly, we cannot have join. So we need to have at least one from condition, right? We cannot have join. So the right answer is B. The syntax is from table A and then join, any join table B and on join condition, right? That's the right syntax. Now we have understood how to work with multiple tables, right? So we also know how to answer business questions in case if we have to fetch data from multiple tables. With that, we have come to end of today's topic. Thank you so much for your time, and we will meet in the next class. Thank you. Bye for now.